Good day, everyone. So today we'll have rational exponents, or we could say the fraction exponents, because again, rational means the numbers that can be put into a fraction. Now, our objective for today is to extend the properties of integer exponents to rational exponents to write radical expressions using rational exponents. Our essential question is, what are the properties of rational exponents? So, what does 3 to the power of 1/2 equal? So you can think of exponentiation as repeated multiplication. As you recall, the 3 squared is 3 times 3, because now you have 3 to the power of 3. That means the 3 is being multiplied thrice, and 3 to the power of 4, it means the 3 is multiplied 4 times. So that is having an integer of a power. But what does 3 to the power of 1/2 mean? You cannot multiply 3 by itself 1/2 times. So since interpreting exponents as repeated multiplication does not work in this case, we must have to define a new meaning for expressions like 3 to the power of 1/2. So whatever the new definition is, you wanted to obey the same rules of exponents that you know for integers, such as the power of a power property. That means 3 to the power of 1/2 to the power of 2. That means 3 to the power of 1/2 times 2 is equal to 1. Because 1/2 times 2, that will give us over 1. 1 times 2 is 2, and 2 times 1 is 2. That gives us 1. That's why we have to the power of 1, and 3 to the power of 1 is equal to 3. So rational exponents, let's define. To define what is meant by a rational exponent, or equivalently a fractional exponent, such as a to the power of 1/3, we need to use radicals. Again, we need to use radicals. So to give meaning to the symbol a to the power of 1/n in a way that it is consistent with the laws of exponents, we would have to have a to the power of 1n is equal to the a to the power of 1n. Again, quantity of a to the power of 1 over n to the power of n is equal to a to the power of 1 over n times n is equal to a to the power of 1, that is a. So by the definition of the nth root, a to the power of 1 over n is equal to the nth root of a. That means nth root of a. In general, we define rational exponents as follows. For any rational exponent m to the power m over n in lowest terms, where m and n are integers and n is greater than 0, we define a to the power of m over n is equal to the nth root of a to the power of m, or equivalently a to the power of m over n is equal to the nth root of a to the power of m. If n is even, we require that a is greater than or equal to 0. With this definition, it can be proved that the laws of exponents also hold for rational exponents. So let's simplify things. This is what is meant. This is our radical sign. This is our radical sign. This is our radicand, and this is our index. Now, if you transform rational exponents, that is the rational exponent, to a radical expression, your m is the power here of the radicand, and your n, or the denominator, is the root. How about for radical expressions, the rational exponents, that is square root of n. Nth root of a to the power of m is equal to a to the power of m over n. Let's have an example for those. Say, for example, here, example A, 4 to the power of 1/2 is square root of 4. How come? Because our n is 1, our n is 2. All right, so square root of 4 is equal to 2. How about here? Our 2 is m and our 3 is n. That's our n, and this is our m. So you have there, cube root of 8 is 2, and to the power of 2, that becomes 2 times 2 is 4. An alternate solution for that one is you can have this. Cube root of 8 cube root of 8 to the power of 2 is 8 to the power of 2 is 64, and cube root of 64, that will give us 4. So you can see here that cube root of 8 to the power of 2 is equal to cube root of 8 to the power of 2. That is equal. Next, how about here? Well, using the definition of rational exponents, so you have there 125 to the power of negative 1/3. So we'll make sure that the negative becomes positive. That's why it goes down to make it positive. So you have there 1 over 125 to the power of 1/3. The 1/3 becomes positive now. So 1 cube root of 125, and your answer is 5. That's why you have 1/5. By definition of radical expression, again, more examples. 5 to the power of 3 is 125. So cube root of 125 is equal to 5. Put that in your calculator, you can see that it is 5. So the index of the radical is 3. Next. What does the fraction of exponent do to the number? 9 to the power of 1/2, the number can be written as a radical expression with the index of the denominator square root of 9. How about here? Again, b to the power of 1n, that is our n is here, and 1 is there. How about here? 64, 3 is here outside, and the 1 is here outside. So cube root of 64, that will give us 4. Double check is in your calculator. How about here? A to the power of 1/6. What would that be? That should be A, and the power is 1. Our 6 is here. Right? How about for m? You have there m, power of 1, and 2 is here. Or simply square root of, simply 6 root of 8. There you go. How about this one? Write each radical using rational exponents. So you have there, this is our, what is it? That should be b to the power of 1/5 and square root of 1 to the power of 1/2. Negative exponents make inverse. So you have again the same problem as what we had. We have there 49 is there, so we make it into a fraction. We will make it positive, so that becomes, that means that it will go down. The denominator is now 49 to the power of 1/2. That becomes positive this time. So 1 is equal to 7, because that is 1 of 49. So what if the numerator is not 1? So you have there, say for example, 32 to the power of 2 to the 5th, that is 2 is here, and fifth root is here. So have there solution fifth root of 2 to the power of 5 because it is 32. 2 times 2, 4 times 2, 8, 16 times 2 is 32. So we have there 2 to the power of 10 to the power. Right, so 2 to the power of 2 is equal to 4. Any questions? You have your partner activity and get your paper for that one. Thank you.